Substandard form is whenever we have a number that looks like it's in standard form, but that it isn't. So our rules for standard form are that it should be a number that looks like a times 10 to the power of n, where a is between 1 and 10, and n is a whole number, either positive or negative. What we have in substandard form are things that are obviously not in that form. So here we've got an example where we've got 12.56. So 12 is not between 1 and 10. And we're also multiplying by 100 rather than a 10. So what we have here is substandard form, and it's doubly substandard form because both components are out of standard form. So the way in which we do that is we express each of the numbers in terms of standard form. So we can see that 12.56, if we're writing that in terms of standard form, it would be 1.256 times 10 to the power of 1. We can also change the 100 so that 100 is 10 squared. We should know that. And I've put it in a bracket because we're cubing the 100. So what we still have here is we're cubing 100. We can write this as 1.256 times 10 to the power of 1 times by 10 to the power of 6. So our rules for indices are we multiply, so 3 2s are 6. And then again, our rules for indices, if we have the same base, so base 10, we can combine these two together to get 10 to the power of 7. Now sometimes we wouldn't write a power in terms of 10. If it was 10 to the power of 1, we might just write that as 10. But then very often, if we were doing 10 times 10 to the power of 7, for instance, a mistake can be as you forget about the power on the 10, and you'd write that as 10 to the power of 7, which we know to be wrong, and we know that it should be 10 to the power of 8. But had we written it as 10 to the power of 1 times 10 to the power of 7, then we would have written it as 10 to the power of 8, and we would have gotten the correct answer. So these examples then, we're going to look at changing from substandard form to standard form. In the first example, it's 123 times 10 to the power of 2, and it's 123 that isn't between 1 and 10. We're multiplying by a power of 10, so it's 123 that we're going to have to change. We can write 123 as 1.23 times 10 squared. So that's dealing with the 123, but then we need to multiply by the 10 squared. So this 1.23 times 10 to the power of 2 is really just this 123, and then we still have the multiplied by 10 squared at the end. Our rules for indices, we've got 10 squared times 10 to the power of 2, and what we know is when they're the same base we add the powers, so we can express that as 1.23 times 10 to the power of 4. We've got a number between 1 and 10, and we've got a power, which is a whole number. So we're good. Second example, what we have is 1.69 times 100 cubed. So 1.69 is between 1 and 10, so it's good. So we need to change the 100. To do that, we'll write it as 1.69 times, and I'm going to put in a bracket, and we know 100 to be 10 squared. 10 times 10 is 100. Using our rules for indices, in a bracket we multiply the powers, so we get 10 to the power of 6. So 2 times 3, which is 6. Example C, we've got 0.03 times 10 to the minus 5, and 0.03 is not between 1 and 10, so it's not correct. 10 to the power of minus 5 is fine, so it's this 0.003 that we need to change. We can express 0.003 as 3, so that's the number between 1 and 10, times by 10. Now because it's a decimal, it's going to be a negative power, and the decimal place has been moved 1, 2, 3 times, or remember, there are 3 zeros altogether. So it's times 10 to the power of minus 3, and then we've multiplied that by 10 to the power of minus 5. Using our rules of indices, we can simplify the two 10s, and what we have is when we're multiplying, we add the powers, so we're going to have 3 times 10 to the power of minus 8. because remember, when we add a negative, it's taking away. For example D, what we can see is that the number part is not in the form of standard form because it's greater than 10. So we need to express that as 6.9355 times 10 squared times 10 to the minus 4. So what we're doing is we're expressing 693.55 as 6.9355 times 10 to the power of 2, where the decimal point has moved twice, so the power of 2. Using our rules of indices, we can simplify the 10 to the power of 2 times 10 to the power of minus 4 and write the answer as 6.9355 times 10 to the power of 2.